With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello, so question is saying this: among the diatomic molecules which are H2, He2 positive, Li2, Be2, B2, C2, N2, O2 negative and F2, the number of diamagnetic species are. So what do you mean by diamagnetic species? So actually diamagnetic species are those species which have a paired number of electrons. So I can say this, which have a paired number of electrons, right? So which have a paired number of electrons in their molecular orbital are considered to be as a diamagnetic, right? So now let us try to solve this question and find out which of the following species is diamagnetic, right? So if I consider it, the first one, that is hydrogen, so this, if I write down its electronic configuration, so it becomes sigma 1s2 sigma 1s star 0, right? So that means in their sigma bonding orbital, we have a 2 electrons and both are paired, right? Both are paired. So that means this hydrogen is diamagnetic. So let me assign here that this is diamagnetic, right? And now move to the second one. The second one is He2 positive, He2, here it is positive. So now if I write down the electronic configuration, so it becomes sigma 1s, so it becomes sigma 1s2 sigma 1s star, because there are two molecules and we have the atomic number that is 2 for 1 helium. So for 2 helium, that total number of electrons becomes 4, and we have positive sign here, that means 1 electron is lost, right? So that means we are left with 3 electrons. I am writing here molecular orbital, so there are 2 electrons are occupied in this orbital, and the left one is here, that is 1. So here you can see this, we have a 1 unpaired electron, so this is not diamagnetic, right? So I can say that this is not diamagnetic, but this is diamagnetic, right? Now and move to the third one is, you can see here, that is Li2, lithium, right? So lithium. So if we talk about the third one, so it becomes, you can see its atomic number is 3, so it has 6 electron. So I can write down here, that is sigma 1s2 sigma star 1s2, right? And sigma 2s2. So you can see here, this is the electronic configuration of Li2 molecule, diatomic molecule, which is based on the molecular orbital theory. And you can see this, all these electrons are paired. So I can say this is also a diamagnetic. This is also a diamagnetic, right? And if we talk about the fourth one, so the fourth one is, you can see here, that is Be2, right? So that is Be2. So Be2, if you can see here, the electronic configuration, atomic number is 4, so that means there are total number of 8 electrons, because one beryllium has 4, so 2 beryllium has 8 electrons, right? So if I write down the filling of the molecular orbital, so it becomes sigma 1s2 sigma star 1s2. Here now it becomes 4 electron, right? And it becomes sigma 2s2, right? And sigma 2s star 2, right? So this becomes 8 electrons. That means these all electrons are paired, so that I can say that this is also diamagnetic, right? Now come to the fifth one. Fifth one is, we have, you can see here, we have B2, boron, right? So if I talk about the boron, B2, that means we have atomic number 5, so it becomes total of 10 electrons. So I can write here that is sigma 1s2 sigma 1s, this is antibonding, star is represented by antibonding, right? So you can say this is sigma star 1s2 here, and this becomes sigma 2s2 sigma 2s star 2. Now it becomes total 8 electrons, right? So now come to the p orbital, right? So 1s 2s and after this 2p, right? So here you can see this. Now come to pi orbital, right? So this is pi 2p 1 and pi 2p, this is, let's say this is the x orbital, and this is pi 2p y, this has a 1 electrons, right? So now total becomes, you can see here, total becomes 10 electrons, and this is not diamagnetic, because you can see here both have a unpaired electrons, 1 in the pi orbital, right? So now move to the third one, that is C2, So if I write down the structure of C2, so it becomes similarly, you can see here, this is C2, diatomic molecule, so it becomes sigma 1s2 sigma star 1s2 and sigma 2s2, that is sigma 2s star 2, and here you can see this, their total becomes 8 electrons, and we have a C2 atomic number 6, so total of number of electrons are 12 because there are 2 carbons. So till here we have 8 electrons, so we have after this pi orbital, right? So this is px, so in it we have a, and this is also p because they have both same energy, this is pi py, right? So pi py, so we have a 1 1, right? So after this becomes 10 electron. After this I can write here as this is 2 here and 2 here, right? So now it becomes total of 12 electrons, and you can see here all these electrons are paired. So I can say this is also a diamagnetic, this is also a diamagnetic, right? So now move to the 7th, that is you can say N2 nitrogen, that is N2. The 7th one is N2 nitrogen. So if I write down the structure of this, if I write down the, you can see electronic configuration of this, it becomes sigma 1s2 sigma star 2 1s2, right? And this is sigma 2s2 sigma 2s star 2, right? So here we have 14 electrons, so till 8 here, and from here you can see this is pi px is equals to pi py. Here you can see this 2 here 2 here, now it becomes 12, right? After this we have a orbital, that is pi pz, and it has a, you can see there 12 here, and here are 2 electrons. Now we have a 14 electron, right? And it means that all electrons are paired, that means this species is also a diamagnetic, right? So now move to the next one, that is O2 negative, right? So if I talk about the O2 negative, so let's say this is 8 O2 negative. So that means you can see here in one oxygen we have at electron 8 and 2 oxygen, so 16, but here this is negative charge, that means we have 17 electron here. So I am writing down the electronic configuration, so it becomes sigma, so I can write down here, that is sigma 1s2 sigma 1s star 2, right? Sigma 2s2 sigma 2s star 2, right? Now there is a change because up to nitrogen there is a sp mixing, so that's why p orbital, this pi orbital comes, you can say pi px and py comes before the pz, right? So now you can say this pz orbital comes first, right? So now you can see here this comes first, so I can say this is not pi, right? So this is not pi because this is sigma, right? So there's a mistake here, so I can remove it. So this is sigma pz, right? So I can write here this is sigma pz because dz or pz orbital makes a, you can see here there's a formation of sigma bond, right? So here because this is according to the internuclear axis, right? Z axis is considered to be internuclear axis, and this will form a sigma bond. So here you can see this sigma bond, this is sigma pz. This sigma pz will occupy 2 electrons, right? Here you can see this 2 to 4 to 6 to 8 10 electrons, and after this we get here a pi orbital, that is pi px is equals to pi py. So here 2 here 2 here, now it becomes how many electrons? 2 to 4 4 to 6 8 10 12 14, and after this we have a pi px, that is this anti-bonding, right? And which is also equals to pi py anti-bonding, right? So here you can see this have a 14, so it becomes 1 here and 1 here, so it becomes 16 electron, right? So but here you can see this we have a negative charge over here, so I can say this, I can write in this way, so it becomes pi 2 negative, right? So it becomes pi 2 negative, so 2 here 1 here 1 here, right? So it becomes 17 electrons, and this is also a paramagnetic, this is not diamagnetic, right? So this is not diamagnetic because we have an unpaired electron over here, right? So we have unpaired electron over here, right? So now move to the F2, right? So move to the F2. So if you talk about the F2, right? So you can see here, if you talk about the F2, let's say this is 9 F2. In case of F2 we have sigma 1s2 sigma 1s star 2, right? So because atomic number is 9, so their total number of 18 electron we have to fill, so that is sigma 2s2 sigma 2s star 2, right? And here because there is no sp mixing, so sigma come first, so sigma pz2 pi px2 is equals to pi py2, so total becomes 2 to 4 6 8 10 12, 14, right? And it becomes pi, px. These are the anti-bonding orbitals. These are the anti-bonding orbitals, right? So you can see here up to here 2 to 4, 4, 6, 8, 10, 12, 14, 14, and here 12. These are 18 orbital, right? So these are the 18 orbital, right? So now you can say all electrons are paired. So I can say this is the diamagnetic species, right? So now let us calculate how many species are diamagnetic, right? So let us calculate how many species are diamagnetic, right? So here you can see this 1, 1, 2, 3, 1, 1, 2, 3, 4, 5, right? So that means if I number it, so let me number it. This is 1, this is 2, this is 3, right? And this is 4, and the last one is fluorine, right? So that last one is fluorine. So I can say this is also a 5, right? So this is 5, and this is also 6. So I can say this, there are the 6 species which has a diamagnetic nature. So I can say this, I can write here as 6 species has a diamagnetic nature. So 6 species has diamagnetic nature. Diamagnetic nature, right? So in this way we can say that there in among these 9 species, 6 species have a diamagnetic nature, right? So hope this answered your question. So thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.